So I will speak a little bit of my work towards this restaurant soundscape simulator. And to recall my PhD work, from the work of how we perceive pristine nature and to the very designed environments in art installations, I see it as being in the middle. We have the servicescapes. So there's something about non-designed, semi-designed and designed environments. There's kind of an axis of designability or intentionality that somehow exists in these environments. And then even more speculative, another orthogonal axis here where we have unimodal or multimodal environments. But the servicescape environments, I find them very interesting because indeed they are they're very designed and they're also very multimodal. So in Schaeffer's soundscape concept, and also in the ISO definition in 2014 that several other people referred to, the soundscape is construed as a psychological phenomenon, really, that originates in actual physical sound sources that are distributed in space and time. So there is this psychophysical collision here that we try to work with. From the Cresson people in Grenoble to Sweden via Björn Hellström and his work, we have these very useful concepts of ubiquity and metabole that refer to how soundscapes can be perceived, or rather how they are, how is it difficult to disentangle the sound sources within the soundscape. So ubiquity refers to a spatial difficulty of understanding sound sources, and metabole about their temporal resolution. Of course, Schaeffer, he introduced several ways of thinking about the sound sources as events. And he referred to them, I think, mainly in two different ways. And one was from the referential aspect, so sound as sources, where we can identify, we can pinpoint the source that I hear. It actually originates in a physical object that I can see, I can touch, I can conceive of. The other thing, the other classification strategy, if you want, that Schaeffer talked about had to do with significance or purpose. And this is where his ideas of sound or sound events as being keynotes or signals or sound marks, that's where it comes in. And of course, this somehow plays into our ability really to perform stream segregation and analysis of this continuous information through our senses, and to separate the stream into events that then, through our learning of language and learning of the environment, we understand as being separated events. So the Cresson, Thibault people, they introduced this concept of synecdoche, which is an isolated event within the whole. Now, I think these concepts here, I find them useful when thinking about how perception can inform design. And I've tried to apply this in understanding better how restaurant environments, specifically soundscapes in restaurants, how they may or may not work. So I started, after a while I should say, I was able to do this fairly large survey of eating places in Singapore. And I and a good couple of assistants, we collected data, psychoacoustic data, so on-site measurement of sound pressure level, and recordings as well, so simultaneously. Physical, so that's basically what we can understand from the environment just by observing. This, I will come back to this. It has to do with size and interior materials in particular, and occupancy, how many people are in these environments. The perceptual features refer to how do we evaluate this? What does the environment do to me as an observer or listener in this environment? And for that last part, I very much rely on the work with the Stockholm group of people, with Mats Nilsson and Östen Axelsson that I mentioned earlier, with the Swedish Soundscape Quality Protocol. So we went to 112 restaurants. We also did photography, so there's part of this, not part of this article, but it's part of it that enabled other research where we could do sort of matching between recorded soundscapes and photography as well. So are people able to somehow recognize photography and soundscape? And yes, they are. Many things in this article, I just point out 2 or 3. This correlation slope where you have the what do you have here? Where you have mean ratings of quality here. So you have low quality and high quality. So when you have a lot of people think that we have low quality environments. So I think somewhere people, when they go to restaurants, they don't quite like other people in there. So keep that in mind as well. So in this, this looks like you take like a hail gun and you shoot a target. But this is a picture of the 112 restaurants, but separated into environments by design style. So that's the bar, buffet, cafe, fast food, hawker, and dining. And also food style. So there's Chinese menu, there's a mixed fusion menu, other Asian, that might be Japanese or Indian or Korean, and of course the Western one. So one, after being able to categorize these 112 places, could then compare or correlate the perceptual evaluations of them, and to find out that indeed quality here on this axis, it depends on sound level, but not as much as you may first imagine, even though there is of course a regression that goes through this way. But it also, the perception of quality also depends on the design style of the environments and things like priciness of comparable menu items, and that's the size of these icons here. But through this study, I got interested in interior design. So this is not at all where I come from. I'm a total amateur, but here, since I had over lunch, I was discussing with some of the architects here, so I will volunteer some ideas from the outside, as it were. So to imagine where are these sound sources? Are they technological, human, or natural, as in their referential aspects? Are they designed or non-designed? Do we know that they are inside the enclosure, the environment, or do we know that they are from the outside? So this I advanced as some kind of typology, really, of sound sources in restaurants. But I felt that it wasn't enough, and I couldn't use it directly then to pursue work. So I had to go to the next step and go away from Schaefferian typology and try to work bottom up with a taxonomic approach instead. So basically I went out to another round of restaurants, 40 restaurants, and asking 10 people at each restaurant, and just ask them, what sounds do you hear around you? And what sounds do you find characteristic for the environment that you're in at this point? And do you like them or do you not like them? So this concept of liking, which is associated with preference, which is associated with pleasantness, eventually. But the really simplest question I think that you can ask people is, do you like or do you not like? Or as we say in Singapore English, like or not. Well, that's Singlish for you. So from that data, so bottom-up data, I constructed the taxonomy. So you see in the middle there's about more than 1,000 original annotations, reduced into a couple of hundreds, analyzed by sound and source in order to find a baseline, if you want, of this taxonomy of that I call sound sources that has 34 units. I think the next, I'll jump a little bit because it comes here. This is an overview of this taxonomy where you have the many and then a reduction in complexity while trying to maintain stepwise the way that these units represent the whole. And that was the important question. Well, here's part of that. And well, this is the liking aspect. So you have, this can be fun to see what kind of sounds do people really not like. Well, I think one talked about footfalls or steps and people walking, screeching chairs are really not liked. And we also have quite low in the negative, a bit, well, in the middle, you see talking people and people. So as seen in other restaurant research investigating restaurant soundscapes, one of the main sources of discontent is really the voices of other people. So I thought that was interesting. And it's also something that other instruments or other studies have, I think, not really explored enough, is the finer nuances of how we, in that kind of public environment, how we relate to other people. So, for example, Mignon and Rosten Busch, or even Axelsson in his work, have quite global categories, while at the level 3 of this present work, we can distinguish between the eating sounds of people, the blurred crowd sounds, and the conversation sounds. And the blurred crowd sounds are heard as very unliked or negative, and conversation sounds such as laughter, and even if you include shouting, for example, it still comes up as being definitely positive. So I have a study currently running now in one restaurant. So that would be a case study, it's running over a longer time, and I also intend to make measurements of things like reverberation time and interviews with the people working in the restaurant and so forth. But the main purpose here is to do yet another validation of the taxonomy, particularly looking at do we need to have an instrument that has a fine gradation of different kinds of sound sources, or can we get by with having one where these sound sources are lumped together and put into categories? How much can we still capture to have a significant representativity of the whole? Simulation is a way of doing analysis by synthesis. I got this from Johan Sundberg, that many of you know, the voice people for sure. So I'm just going to blast through a couple of ideas here that relate to the to working with creating a simulator. Well, from Valle, he's writing about the importance of letting the user of a simulator be able to sort of explore different parts of this as an environment, and to give it to the user to be very active. And I think that's an important thing with a good simulator. What we can learn from Thorogood is, well, he relies on about Truax, listener recognizability of the sound source material to maintain that. So that's basically rather use recordings and do not synthesize sounds as much. You need to somehow work with real things. And their work is interesting because they bring in the emotional, the affect perspective here as well in their user interface that you see a picture from. And the third method, if you want, is to employ some like machine learning. Accolti and his Italian team, they have a method, so it's a quite technical method, but it has to do with how you optimize among a large number of candidate sources to use in a simulation. You can find the optimal one by using a cost function that minimizes the difference between your candidates and the target sound frame. And then they also have strategies for working with realistic temporal distribution of sound events. Bottledoren has also done this. So this is sort of the stage of my prototyping working now. What I can do here is to work with the concept of the different levels of the taxonomy, 4 levels at this point, and sort of load the units inside. So for level 2 here, there's 13 different categories that you see. So I can select, well, now it's already selected blurred crowd sounds. It will call up files that, of course, so here in this version there's something like close to 560 sounds, and they have been gathered from freesound.org using the annotations in there. And what I want to do, I know there's an SDK for how you can do automatic retrieval of sounds from freesound.org, and of course it would be great to automatize this, right? You just type in keywords and you get 2,000 sound files onto your computer, and it's entirely possible. So that will be one step further with this system. Not quite there yet, so I pick items within the different categories that match the semantics, so the annotations, and yes, I do some basic modeling of the things like this. So this is a Gaussian distribution of you see here. So a new sound that's being called in, it will not always be played back at the level, the amplitude, but rather a Gaussian distribution around a typical value. And same thing for the distance perspective. So here there's always listener in the center and a quadraphonic specialization here, but there's a concept of typical distance that we can work with. And what is the third thing I want to say? Yes, quite importantly, we need to model when to trigger new sounds within a category. So what Croissant and Hellström said about ubiquity and metabol has to do with sort of the consistency, the stability of these environments. And I think that can work for environments such as restaurants, that they have predictable static qualities. So that is also, yes, this is where I model this now with a curve that looks like this. Oh, I just sort of fake a little bit here. This is a sort of a double logistic curve where there's a flat part here which represents the sustainability rate. So there's a rate of triggering new files within this category that would make it keep on forever. But if we have too few of them, then we'll be on the left side of this graph, and we have a higher probability of triggering sounds in that category. By contrast, if we have too many or more playing that we would want, then we would be on the lower part here, the right part. So this is really a very much a prototype system. in the implementation and trying to make this work and sort of keep track of what are the global parameters that we will want to work with. Of course, I will want to use this in a user experience study eventually, and also compare it with actual recordings of restaurant soundscapes. But that is future work. So thank you very much for your attention.
Thank you very much, PerMagnus. This was really hardcore programming.
No,